So this question has a lot of words in it, but let's read it through together. It says two disks are mounted on a low friction bearing on a common shaft. The first disk has a rotation inertia I, the spinning with omega. The second disk is rotating with 2I and spinning in the same direction as the first disk with 2 omega. The two disks are solely forced together until they couple and have a final common angular velocity of what? Well, this looks like a very good use. This looks like a collision. And when we have collisions, it's a rotating collision, but it's a collision nonetheless. And when we dealt with collisions, we want to deal with momentum. And specifically, we want to deal with angular momentum. So our total initial angular momentum is going to be equal to our total final angular momentum. And we know that the momentum is defined as I omega. So I'm going to say they're spinning in this direction. So if I actually turn my hand, I'm going to say that this is the positive x direction. They're spinning in the positive x direction, right? My fingers wrap around in this direction and point in the direction, the x direction. So that means I get a total equation for conservation of momentum that says I1 omega 1 initial in the x direction, the positive x direction, plus I2 omega 2 initial, again, it's in the positive x direction, so I add them together, is going to be equal to, well, they couple together. So this is going to be I1 plus I2, and they're going to both end up with the same final momentum, or angular momentum. They're not angular momentum, it's going to end up with the same final angular velocity. And this looks like just an inelastic collision, but rotating, and that's what it is. So let's plug in some values. We say we have I omega plus 2I times 2 omega. 2I, 2 omega, 1I, 1 omega. And this is going to be equal to I plus 2I times omega final. And I will see that this gives me 5I omega, 1I omega from here, and 4I omegas from there is going to equal 3 I's here and an omega final. My I cancels with my I, and I get 5 omega over 3 is equal to omega final. So when I get to the very end, I guess I didn't have to move the paper, but when I get to the very end, I see answer choice A is the right answer. I omega, 2I, 2 omega, when they stick together, they combine their total moment of inertia, and they get a final omega for this.